Okay, folks, we're going to move back in to 9.5. We were previously in 9.5 and we did two separate video lectures on that. And back in those two prior ones, we were rationalizing a denominator that contained one term. The first video, the denominator that contained one term was numerical in nature. And in the second video, the denominator that needed to be rationalized was a single term that contained variables. Now we're going to come back to 9.5 and we're going to actually finish the entire section by rationalizing a denominator that contains two terms. Now the final comment that was raised in 9.4 was multiplying conjugates together. And we did two problems of that type. And in each one of those cases, we came up with a similar kind of structured solution. Whenever you multiply conjugates together, you get a rational number. Yes, I know that I mentioned in that video that you would get a real number. Well, a rational number is a form of a real number. You get a rational number. You get an answer that contains no radicals at all. So now we're going to complete the last part of 9.5, which is rationalizing denominators containing two terms. A denominator that has a binomial in it. And here is that type. And then we'll talk the rule. 4 over 7 plus radical of 2. We can't leave that problem in that manner because there is a radical in the denominator position. And we cannot have radicals in denominators. The difference is it's not that look. That was the look in the first video of 9.5. Now this is the last one. We're looking at a binomial, of which part of that binomial contains a radical. We can't have a radical in the denominator. So up here in red, I don't know if it's showing red on the video, but up here in red, here is the rule of how we rationalize a denominator that contains two terms. To rationalize a denominator containing two terms, we multiply both numerator and denominator by the conjugate of the denominator. So, let's look at the denominator. The denominator is the binomial 7 plus radical of 2. The conjugate of 7 plus radical of 2 is 7 minus radical of 2. I just kind of wrote that little binomial off to the side. Why are these two conjugates? Because conjugates are two binomials that only differ in the signs between the terms. You see, these two binomials both begin with a 7, and they both end with a radical of 2. The difference is one is plus, and the other one is minus. So the conjugate of 7 plus root 2 is 7 minus root 2. And so back to our rule. To rationalize a denominator containing two terms, we're going to multiply both numerator and denominator by the conjugate of the denominator. And the conjugate of 7 plus root 2 is 7 minus root 2. And we're going to multiply both numerator and denominator by that. So there is the look. There's the look that we've got. So we're going to bring down a line. And I'm going to go ahead and tuck that binomial there, and I'm going to tuck that one as well. And for good measure, I'm going to tuck him. Now we've got to multiply 4 times him. Well, let's write it like this first. And on the bottom, since these are conjugates now that we're going to multiply together, we're not going to worry about the outer and the inner. We're just going to multiply the first, 49. And we're going to multiply the last. Positive times negative, negative root 4. Now, go back and we'll bring down a bar. We will go ahead and distribute this. You actually would not need to do it at all, but we'll go ahead and do it. 4 times 7 would give 28, negative 4 root 2. And on the bottom, we would have 49 minus 2. And our answer would be then 28 minus 4 root 2 over 47. Now, folks, I'm pointing down here because I want to make a key point before I move to the next problem. When you're rationalizing a denominator that contains 2 terms, you could end up with a situation at the bottom to where you might have to do a little reducing. Meaning, we have a binomial on top. This is one term, and this is the second term. And if you look at both of those terms, they both contain a common factor of 4. There's a 4 in 28, and there is a 4 in 4 root 2. So we could take out a GCF out of the top of 4. But when we take that out, we would only take that out if we were going to be able to do some reducing. And we're not going to be able to be doing any reducing on this one because the denominator of 47, it is rational, but the denominator of 47 is prime. And we're not going to be able to do any cancellation whatsoever. So, that is an answer to that given problem. And we have rationalized the denominator. You see, the original denominator was irrational because of him. But because we multiplied both numerator and denominator by the conjugate of 7 plus root 2, which is 7 minus root 2, we ended up getting a rational number in the denominator, and we have given what they've wanted. We've rationalized the denominator. Okay. Let's go to number 2. 6 plus root 5 over root 5 minus 9. Put a time sign. Get a new fraction bar ready. The denominator is a binomial. It contains a radical. Because it's a binomial, we're going to have to multiply both numerator and denominator by the conjugate of this denominator, which would be the radical of 5 plus 9 there, and the radical of 5 plus 9 on the top. Go ahead and tuck both of those, and tuck both of those. And we'll bring down one line. Let's go to the top. Let's multiply the first terms because we're multiplying two binomials there. So we'll have 6 root 5. Let's do outer. Positive 6 times positive 9. Let's do inner. Positive 5 times positive 5. In other words, positive root 5 times positive root 5. Positive root 25. And then the last, positive root 5 times 9 plus 9 root 5. Come down on the bottom. Let's take care of the bottom. We're multiplying conjugates. Multiply the first terms. Root 25. Multiply the last. Negative 81. Draw a line. Carefully here. 6 root 5 can be combined together with 9 root 5. I would have probably ordinarily shown a little bit more work but I don't have a whole lot of space on this board and I'm kind of always running up against time, so I'm trying to save a little time. 6 root 5 can be combined with 9 root 5, which would give 15 root 5 plus 54 plus the root of 25, which is 5. The bottom, he's coming out, and we'll have 5 minus 81. Now, we can leave this in this fashion right here. 15 root 5. Combine the 54 with the 5 for positive 59. And then 5 minus 81, or a positive 5 combined with a negative 81, should be a negative 76. You can leave your answer this way. There is nothing wrong with that answer. But when you check in the back of the book for your answer, they will not leave the negative sign down there by the denominator. I'm going to slowly do this. You can leave the answer just like that. But when you check the answer in the back of the book, they're going to take this negative sign right here, and they're going to put it even Steven with the fraction bar, and they'll put it right there. And I'll go ahead and put it there as well. It is not a better answer than the original one that I had, but I changed it. It's number 2. It's rationalized. No more radicals in the denominator. Okay, maybe 3 times the charm. Let's do that third one. 11 over radical of n plus 8 times sign, fraction bar, binomial, radical, have to rationalize, but it's 2 terms, so you got to use conjugate. The conjugate, the radical of n minus 8, the radical of n minus 8, tuck him, and tuck, and get the line. On the top, just right initially, 11 times the quantity of radical of n minus 8. Bottom, they're conjugates. Multiply the first terms. Radical of n squared, multiply the last. Negative 64. I'm glad this occurred because I want to show you the alternative. When I did the very, very first one, I distributed out that top. But on this one, you don't have to. You can leave it 11 times the quantity of the radical of n minus 8. On the bottom, he's coming out and we'll have n minus 64 for that. He's rationalized. How do I know that he is? Because there's no radicals in the denominator. Why did I leave him this way? Because you never know what you're going to see down here in this denominator. If this denominator would have been, let's say, a 66, if it would have been a 66, you could have canceled and reduced the 11 with the 66, and you could have simplified it more. If you wish to distribute out the top and write it as 11 root n minus 88, you go right ahead and do it, but you can leave it that way and it is fine. But if I can just do number 4 right here before we call it, I think I can get by with just number 4, because number 4 is not a situation where you're going to have to rationalize any denominator. Let me copy the problem down and set into motion what I'm going after. Let's say this is the direction. And you're looking at the following. Now, let me set the situation here. Let's say you were given a problem where you had to rationalize the denominator and you had to use conjugates because the denominator was a binomial. And let's say you went through all the conjugate stuff and all the process and you got your answer down to this, where you see the denominator has become rational. Sometimes, not all the time, but sometimes you're able to take an answer and reduce it. This one can be reduced. This is a binomial on top. This is term number 1, and this is term number 2. And each one of these terms has a common factor that they both share. This term contains a little common factor of 4, a little factor of 4. There's also a 4 in 20. So we can take out the GCF here. And because we're able to take out a 4, and we have a 4 positioned in the denominator, we're going to be able to reduce. It's something that you should always look at. I'll put him down there. Pull out a 4. Divide this guy by 4. They go. You're left with him. Negative 20 divided by 4, negative 5. Folks, the 4's cancel out to 1s. And your answer without any parenthesis at all would be the radical of 6 minus 5. And that would be the given answer. So it's something that we kind of have to be aware of when we're doing it. It's always something to look at. Now we'll close it off. There will be now one more section that we'll have to do, and that will be 9.6. And that will be coming up next. Keep a smile. Thank you. Bye.